Welcome and hello. This is a video exercise in HEC RAS. And in this exercise, we're going to be dealing with inline structures for a steady state simulation. All right, just to give a little direction here, I brought up the problem statement and it reads, how many sluice gates measuring 10 feet tall by 20 feet wide are required to prevent overtopping of the inline structure when the channel flow is a constant 10,000 CFS? All right, so I know that doesn't give all the details required, but it does give us a general idea of where we're going with this exercise. So let's get started. File, New, and let's navigate to the directory we want to save our project in. Okay, and then give that project a title. I'm going to call this exercise 10, call it whatever you want, and OK. And here we want to click OK just to accept the US customary unit system. All right, let's go ahead and get started. I'm going to sketch a geometry file first. So down here in the geometric data editor, you can open that up with edit geometric data and then click on river reach. Start with a single left click to start the reach, and we're going to be sketching in the downstream direction. So I'm just going to give it a little curvature here and then double click to terminate that reach. I'm going to give it a name here, river A reach 1. And there is our reach. Next, I'm going to open up the cross-section editor and create a few cross-sections. I'm going to start by just going Options, Add New Cross-Section, and we're going to start at River Station 0. All right, so I'm going to type in the values for the cross-section coordinates. This is going to be facing downstream. All right, once those are all typed in, then we're going to come over and just type in 0 for the downstream reach length, because this is the cross-section at the very bottom of the reach, and then Manning's N values. And then after that, the bank station will be at 300 and 700. All right, so if I click on Apply Data, I'll get a preview of that cross-section over here to the right. Next, what I want to do is add a cross-section at the top of the reach and then create a few intermediate cross-sections via the interpolation tool. So I'm going to go Options, Add New, Copy Current Cross-Section. That'll make it a little bit easier. I'm going to say that it's at River Station 5000. And what I want to do is type in 5000 here for a reach length to the next downstream cross-section. And then for the elevation, I'm going to add 25 feet. So if I go Options, Adjust Elevation, add 25 feet. All right, so that would result in a 0.5% channel slope for this entire reach. So I'll click Apply Data. And then if I close this, I have my two cross sections now. The cross section at River Station 0, and then at the top of the reach, which is cross section at River Station 5000. All right, to add a few intermediate cross sections, we can do that quickly by just going up to Tools, Cross Section Interpolation, within a reach. And then what I want to type in here is every 1,000 feet. And this is all river stations for the reach. Okay, so interpolate and close. And just like that, I've got my intermediate cross sections, which are just a linear interpolation between the two that I manually defined. All right, next step, I want to go ahead and save this geometry file before I forget. So File, Save Geometry Data. Now I'm going to call this geometry file 3 gates. That's going to be the title, and you'll see why. That's going to be the starting number of gates we're going to use for our first guess. So I'm going to click OK, and then just we'll return to that idea in just a moment. Next, I'm going to click Inline Structures right here. So the inline structure will go across the channel, and we'll see that in just a moment. So Inline Structures, and then what I'm going to do is Options, Add an Inline Structure. This will be at River Station, let's go with 2400, and then click OK. So the upstream cross-section is 3000. That's this one here, and I think that's the cross-section we're seeing right here. I'm not going to do a description, no pilot flow, no culverts. What we're going to do is add some gates. But before that, I need to add the weir embankment. And what I'm going to do is basically wall off this lower section of the main channel and then put the gates in there. So in the event of a 100-year flood, there'll still be plenty of overbank area for the flow. Okay, so I'm going to click weir/embankment. And then what I want to do here for the distance, this is the distance downstream from the next upstream cross section of 3000. So I said 2400 right here, so that would be 600. And then for width, right here, this is the width of the weir or embankment in the direction of the flow. So let's just throw a number in there, 40 feet. And then for the station data, what I want to do, station and elevation data, is let me take a look at the cross section once again. So let me go down to here's 2000 and then here's 3000. So the overbank elevation at 2000 is 70 feet. And then if I go up 1,000 feet upstream, it's 75. And if I'm 40%, then that would be 72. So I'm going to come back to this editor here, and station 300 is where I'll start. Say it's 0, and then I'll go up to 72. And then 700, I believe, is the cross-section river station of the right bank up to 72, and then back down to 0. All right, everything else here looks fine. Actually, I'll go 2 to 1 on the side slope, and then broad crested weir's fine, and okay. So what I see now in the diagram here, I'll zoom in a little bit. Oops, sorry. Let me just modify this view real quick to, and then click OK. Okay, I should be able to zoom in now. There we go. So what I'm seeing is River Station 2000, 3000, and then here is the inline structure at River Station 2400. Okay, I'm going to zoom back out now, and then just put that right there. Back to the editor. Here we have what looks like the inline station. I thought this was going to be flush, but I might be off a little bit. Anyway, we'll go with this. The weir and embankment data is done. So I'll click OK to that. And now let's go ahead and add a gate. Specifically, 3 gates is going to be our initial guess. So open up gates. And now in the gates editor, we're going to go with sluice gates right here. That's the default gate. Our gate group is called gate group 1. That's fine. It starts us off with 1 gate group to start. And then we'll put the individual gate openings down here, as long as all the other properties that we define are consistent. So all the properties like height, width, and invert, those should all be the same for the entire gate group. Okay, so the discharge coefficient, we'll say 0.5. The height I said was 10 feet. And then the original problem statement, it says 20 feet wide. And then the invert, let me go ahead and take a look at this. So here's the cross section. Let's put the invert at 50 feet. So I'll type 50 in right there. And then that image will update in just a moment. But now we need to specify the number of openings. So I'll just call this gate 1 for G1, G2, and G3. It's going to be centered at River Station 500. So let's go ahead and put G1 in the center as River Station 500. And then gate 2, if it's 20 wide, I'll give it a 10-foot buffer between the edge to edge of gates. And then we'll go 470. Okay, so everything else looks fine. Click OK. Here are the 3 gates in our inline structure. These gates are actually twice as wide as they are tall, but because the scale of this image is a little bit warped, then they look like they're taller than they are wide. All right, so I'm going to go ahead and close this file, save the geometry data. Let's go ahead and add that flow data. The original problem statement said it was a steady flow of 10,000 CFS. So I'm going to go edit steady flow data. For the boundary conditions, let's go ahead and use a normal depth, and then the slope is going to be 0.005. Okay. And then click OK. We're only going to have one profile here, and this is going to be the 10,000 CFS. And something else we need to do now is go options, gate openings. There's 3 gates with a total height of 10 feet. So those are sort of the limits on these 2 fields right here. We're going to open all 3 gates all the way, 10 feet. If you wanted to just open 2 gates, you would just type a 2 in here. Oops, 2. If you only wanted to open it up halfway, you type a 5 in here. But we're going to go all the way, oops, which is 3 gates, all open 10 feet wide or 10 feet high. All right, so OK, and then file, save flow data. I'm going to give this the name 10K underscore 3 gates. Typically, I wouldn't specify gate information in the flow file data, but because of that boundary condition of what the gates are set to, I'm going to go ahead and do it that way. Okay, so OK, so that's been saved. I'll click close. We have our files up here ready to create a plan, our geometry data, our flow data. So I'm going to go run steady flow analysis. Now I'm going to save this as, again, 10K, 3 gates, and OK. OK. All right, looks good. So I'll click compute and that finished. So now I'll click close, view cross-section data. Okay, so right now I'm up River Station 4000. Let me go down to our inline structure. And what it looks like is it looks like all three of the gates successfully convey the 10,000 CFS passing through it fine. But the water surface elevation you can see is right here. So all gates are fully submerged and fully flowing. So the question asks how many gates are required. So there's a chance if we take away one of these gates and the water surface elevation doesn't rise above the top of the inline structure, then that would actually be the correct answer. I don't think that will happen, but it's something we need to check. Also, if we added a gate, the water surface elevation upstream of the inline structure would decrease. It would come down a little bit, but would it come down so far that the gates are no longer fully flowing? So that's another question. So what we're going to do in the remainder of this exercise is go back to the geometry file and then modify the number of gates. Let's go with 2 gates and also 4 gates, rerun the simulation, and then take a look at the results. All right, so I'm going to close this up. Few other results I wanted to look at is water surface profile. Here we see the water surface elevation from a side view. Here's the inline structure, which is at River Station 2400. And then we see the water surface sort of backing up and then flowing through the gates. And then there's the downstream water surface elevation. One other plot I've always kind of liked is this XYZ perspective plot. And here we have the flow. Let me go ahead and change the upstream and downstream river stations so it zooms in just on the inline structure. Okay, so there's that. All right, anyway, back to the geometry file. Currently, I have 3 gates loaded, so I'm going to go File, and then let's save this geometry data as, let's go with 2 gates, and then click OK. That way, all we have to do is change the number of gates. So I'm going to go back to inline structure. I'm currently editing the 2 gates geometry file. I'm going to click on gate. Let's delete this gate right here and click OK. All right, poof, it's gone. And then let's go ahead and save that geometry file. Next, I'm going to create a new flow file. And the reason I'm doing that is because we need to preserve the original boundary conditions of opening 2 gates. File, save flow data as 10K underscore 2 gates. Okay. And then I'm going to go up to options, gate openings. There's only 2 gate openings, so I'm just going to change this 3 to a 2. And okay. And file and save data. Okay, I'm going to do the same thing but for 4 gates now. So in the geometry data, it's going to save me a little time if I just open up 3 gates to start with and open. All right, and then file, save geometry data as. I'm going to change that 3 to a 4. Click OK, and I'm zoomed out for some reason. There we go. I'm going to click on inline structure. We have 3 gates now. Let's go ahead and add a gate. This will be G4. Let's put it at 560 and click OK. I realize the gates are no longer centered because we started with an even number and we centered it then, but it's all right. I'm going to close this file, save geometry data, and now I need to go ahead and modify the flow data once again. Edit steady flow data. I'm going to go File, Save Flow Data As, and now I'm going to just change 2 to a 4. Click OK. And then in the options, I'm going to go Gate Openings. There's 4 available, and then I'm going to change the 2 to a 4 there. OK. File and Save Flow Data. All right, almost done. Let's go ahead and run the simulation now. To do that, I'm going to click on the running stick figure icon here, which is the same as Run Steady Flow Analysis. What I have is 4 gate simulation ready to go in the geometry file and the steady flow file. So I'm just going to go ahead and save that. And then, oops, I got 2 gates on my clipboard. Call that 4 gates underscore 10K. Or I guess I should have gone 10K, 3 gate. Let's do it this way instead. All right. So this is the plan file. Okay. Okay. And save and compute. Okay, so we'll take a look at those results in just a moment. What I want to do is run the 2 gate simulation now. New plan. I'm going to call this 2 gates and OK. 10K 2 gates. Okay. And I'm going to change this to 2 gates here, and also the flow file for 2 gates here, and then file, save the plan, and compute. All right, that looks like it ran. So let's go ahead and take a look at the results. We got the 2 gates simulation data in place now, so let's just look at that first. View, cross section, and we have some overtopping. So that answers our question. The fewest number of gates required would be 3 gates because 2 gates has overtopping. Something else we can look at while we're here. Oops, if I go up to view, we can look at the water surface profile. And yep, a little bit of overtopping when running the 10,000 CFS flow through the 2 gate scenario. And then view XYZ perspective plot. This is for 2 gates once again. Let me go ahead and zoom in by setting the upstream reach to 3,000, the downstream reach to 2,000 right there. And it's kind of hard to tell the water surface elevation from this one. I guess you can kind of tell from there. Can I zoom in? Something like this. Okay, that's better. All right, let's go ahead and take a look at the results from 4 gates. So how low is the water surface elevation in that situation? Let's start with cross section, and then for options, let's change the plan. I'm going to toggle off 2 gates and toggle on 4 gates, and then click OK. It looks like the water surface elevation, see, this image didn't update. The water surface elevation is just above the gates, but I was expecting to see 4 gates here. See, inline structure. Yeah, this image looks a little goofed up. All right, hold on. Let me go ahead and check the other results. So water surface profiles, this looks correct. So this is the side view again of 10,000 CFS routed through the inline structure with 4 gates fully open. And then the perspective plot, the view XYZ perspective plots. Okay, so if I rotate this and rotate that, options, zoom in again, maybe just right on the inline structure. This is the top. This is the side. This is the front. And then this is the side. Okay. All right. Well, that was it for this exercise. What we did is created an inline structure and a constant flow and determined how many gates of a fixed size and orientation were required to pass that flow through the inline structure without overtopping using HEC RAS.